Hi again, this is Chingster. Welcome to my video on parallel lines and transversals. First, we'll look at coplanar lines. In case you're wondering what coplanar lines are, think about the word co and planar. So we know that collinear points are points that lie on the same line, and coplanar lines will be lines that lie on the same plane. So you can think of it as lines that you draw on a flat surface. All right, this pair of lines are coplanar, and then maybe they may be going this way or this way. And now if we draw a line that cuts across these lines that we have drawn, and the lines in red has a special name, and we call them transversals. Now let's write down the definition of a transversal. A transversal is a line that intersects two or more coplanar lines in different points. So we're going to look at how the angles are formed and what names are given to them. Now we'll look at angles formed by two coplanar lines and a transversal. First of all, let's draw two coplanar lines. Okay, so remember, these two lines do not have to be parallel. So as long as they're coplanar, that's fine. And I'm going to draw my transversal. I'm going to put it in red. So my transversal in this diagram is a line in red. And you can see that there are now 8 angles formed. So I'm going to call them angle A, B, C, and angle D, and then angle E, F, G, and angle H. So from here, you could see that there are interior part of the two coplanar lines. So interior angles, they are on the inside here. And then we have the exterior. So exterior angles that are on the outside of the two coplanar lines. The interior angles will be angles C, D, E, and F, and the exterior angles are A, B, G, and H. Let's also label the transversal. It's right here. This is transversal. And you can see that angle A, D, E, and H are on the left side of the transversal, and angle B, C, F, and G are on the right side of the transversal. So let's look at angles A and angles E. You can see that they are both on the left side of the transversal, and they are both above the two coplanar lines. And we have a name for this pair of angles, and they are called corresponding angles. Corresponding angles, as the name suggests, are two angles in corresponding positions relative to the two lines. In this example, we will be looking at angles A and E, which are on the left side of the transversal and above the two lines, and angles B and F, they are also above the two lines and on the right side of the transversal. And we also have angles C and angle G. They are both under the two lines, below the two lines, and on the right side of the transversal, and angles D and angle H. Now we're going to look at the angles on the inside of the two coplanar lines, and we call them the interior angles. So let's look at angle D and angle E. You can see that they are both on the left side of the transversal, and they are both interior angles. And we call them the same side interior angles or co-interior angles. There are two interior angles on the same side of the transversal. In the example here, we can see that angles D and angle E are two same side interior angles, and angles C and angle F are a pair of same side interior angles. The next pair of angles that we're looking at are angle C and angle E. So C and angle E, you can see that they are on the alternate sides of the transversal and they are both interior angles. So they are called the alternate interior angles. If you want to know the definition, you will call them the two non-adjacent interior angles on opposite sides of the transversal. In this case, we're talking about angles D and F, and also angles C and E. Some of you may be wondering, is there a name for angles A and G and angles B and H? Yes, this pair of angles are called the alternate exterior angles. And they are two non-adjacent exterior angles on opposite sides of the transversal. Let's first draw two parallel lines. I have a line here, and I'm going to draw another line through this point here. So I'm going to use the feature here, construct parallel line. You see these two lines are parallel, and I'm going to draw a transversal intersecting the two lines. I'm going to now change this color, the transversals color, to red. So we can see that the angles formed here, we have the 8 angles formed by the parallel lines and the transversal. And let's measure the angles. So if you have, this is our first angle. So this angle will be, the measure is 105.42, and the adjacent angle, okay, let's just first find out all the measures of the angles. CBE, and you can see that angle ABC is congruent to angle DBE. So these two angles are congruent here, and this angle here, these two angles are congruent. So these two are the vertical angles, and these two angles are congruent. Okay, let's see what happens when, let's find out the measures of the rest of the angles. So this is 105. So you see that this angle here and this angle here, they are congruent. Okay, and so angle BEG is over here. It's the measure of angle EG, sorry, it's angle GEH, and we have this angle here. Let's find out the measure. So you can see that over here we have congruent angles. So you have angle ABC is congruent to angle BDE, and they are vertical angles. And we also have angle ABC is congruent to angle BEF. And what do you remember the name for this pair of angles? They are the corresponding angles, and ABD is congruent to BEG, same measure, 74.58, and DBE angle is congruent to angle GEH, same measure. So from here you can see that when the two lines are parallel and they're cut by a transversal, the corresponding angles are congruent. How about the alternate interior angles? Let's see. So CBE, this angle is also congruent to angle BEG, and DBGE, this angle here, is also congruent to angle BEF. So the alternate interior angles are also congruent. And what about the same side interior angle? So this angle here and these two angles here, let's find out, is there any special relationship? I'm gonna try just adding them. So let's see. So calculate I'm gonna find the sum. Okay, I'm gonna add this angle to this angle here, and you see that they add up to 180. The sum of these two angles add up to 180. And it will be the same for these two angles. And from here, it doesn't matter how you move them. The angle measures are the same, and the sum of the two same side interior angles, or the co-interior angles, are supplementary. So we're going to come out with the properties for parallel lines and transversal. Now let's go back to the diagram. I'm going to have two parallel lines, so I'm going to label them with the arrow to denote that these two lines are parallel, and the transversal is in red, and label the angles A, B, C, D, E, F, G, and H. We saw from our earlier investigation that when two parallel lines are cut by a transversal, certain angle pairs are congruent and certain angle pairs are supplementary. So let's write down the properties. When two parallel lines are cut by a transversal, we know that angle A is congruent to angle E, and angle A and angle E are corresponding angles. So this is the property that the corresponding angles will be congruent. Therefore, angle A is equals to angle E, angle B will be equal to angle F, and angle D is equals to angle H, and angle C is equals to angle G. So C equals to G. I would call this like an F shape, like for example, this is like the two angles, right? It's like an F. So if you have like two angles here and they are corresponding, it's like drawing an F around them. You see that? It's like an F. What about the alternate interior angles? We saw from our earlier investigation that alternate interior angles are also congruent. So we have angle D and F. They are the alternate interior angles. They're congruent. So angle D is equals to angle F. And also we have angle E and angle C. So C is equals to angle E. And if you want to look at it, they look like a Z shape here and then a Z shape here. So I would draw it. If I draw two lines here, two parallel lines, and I have the transversal, the alternate interior angles will look like a Z shape. Yep, that's how I look at it in terms of like a picture. Our next property is on same side interior angles, and we could see from our investigation earlier that when two parallel lines are cut by a transversal, the same side interior angles are supplementary. So we have angles E and angle EF, they add up to be 180. And angle C and angle F will add up to give you 180. So D plus E equals to 180, and also C plus F equals to 180. And I look at it as like a C shape. it's a C shape, and then this is also like a C shape. So when you draw two lines and the two angles are in the C, it's like a U or a C. So that's how I look at it. And also, if you are interested, you can also investigate or check whether what happens to the alternate exterior angles, whether is there any special property for them. And read my notes below to see whether there's any property for alternate exterior angles. Then that's it for my video, and thanks for watching, and don't forget to subscribe. See you soon.